Let us discuss the third problem. Take down the third problem. A body of mass 10 kg, a body of mass 10 kg, a body of mass 10 kg, a body of mass 10 kg is suspended, a body of mass 10 kg is suspended from a helical spring, suspended from a helical spring having a stiffness of 2 Newton per mm, having a stiffness of 2 Newton per mm, damper having a resistance of 5 Newton, damper having a resistance of 5 Newton at a velocity of 0.1 meter per second, at a velocity of 0.1 meter per second is connected between the mass, and the fixed end of the spring, is connected between the mass and the fixed end of the spring. Determine first one, the ratio of successive amplitudes, second, third one, the value of K is given, that is 2 Newton per mm. So we need to convert it in terms of meters. So it is 2000 Newton per meter. Then we need to find out the value of C, because F value is given, that is 5 Newton, and velocity is given, that is V is equal to x dot is equal to 0.1 meter per second. We know that F is equal to C into x dot. So C is equal to F amplitudes, ratio of successive amplitudes. We need to find out the ratio of successive amplitudes. The ratio of successive amplitudes is given by the equation xn divided by xn plus 1 is equal to e raised to delta. It is given by the equation, the ratio of successive amplitudes is given by the equation xn divided by xn plus 1 into e raised to delta. So how to find out the value of delta? If we get the value of delta, we can find out what is the ratio of successive amplitudes, that is xn by xn plus 1 is equal to e raised to delta. So how to get the delta value? We don't know what is the delta value, but we know what is the equation for delta. The equation for delta is given by 2 pi zeta divided by under root of 1 minus zeta square, right? We know that delta can be found out by the equation 2 pi zeta divided by 1 minus zeta square, but we don't know what is the value of zeta in that equation, so we need to find out zeta. So how to get the value of zeta? The value of zeta can be found out by using the equation C by Cc, right? The value of zeta can be found out by the equation C by Cc, but in the problem statement only C value is given, the Cc value is not given. So it means we need to find out the value of Cc also. So how to get the value of Cc? The value of Cc is given, that is 10 kg. You can find out what is the value of omega. So then you can substitute that value of omega into the equation of Cc is equal to 2m into omega n, and you can get the value of Cc as 282.843 Newton second per minute. So you got the value for Cc. Once you got the value for Cc, then substitute that one into zeta equation, that is nothing but C by Cc. So you know what is the value for C. The value for C is 50. The value for Cc already you have found out, that is 282.843. So you can find out the value of zeta. The value of zeta is 0.1768. So once you find out the value of zeta, then you can substitute into the equation of delta, that is the delta is equal to 2 pi zeta divided by under root of 1 minus zeta square. So you know the value of zeta, 2 pi into zeta is 0.1768 divided by under root of 1 minus 0.1768 whole square. So you can get the value of delta. So the value of delta is 1.1286. Once you get the value of delta, then you can substitute into the governing equation of ratio of successive amplitudes, that is xn by xn plus 1 is equal to e raised to delta. So this is equal to e raised to 1.1286. So the ratio of successive amplitudes is 3.0915. 3.0915. So one thing we have calculated, that is ratio of successive amplitudes. Then what they have asked is the ratio, in the second question is amplitude of the body they have asked after 10 cycles if the initial amplitude is 15 mm. So let us go for the second question. The second question is amplitude after 10 cycles. Amplitude after 10 cycles they have asked. So x0 by x10 is equal to x0 by x1 multiplied with x1 by x2 multiplied with x2 by x3 multiplied with x3 by x4 multiplication by x4 by x5 multiplication by x5 by x6 x6 by x7 x7 by x8 x8 by x9 x9 by x10. So x0 by x10 can be written as x0 by x1 into x1 by x2 into x2 by x3 into x3 by x4 up to x9 by x10. So this can also be written as x0 by x10 can also be written as x0 by x1 whole raised to 10 x0 by x1 whole raised to 10. So therefore x0 by x10 is equal to x0 by x1 value already we have calculated, that is 3.0915 raised to 10, which is equal to 79735.46. So x0 by x10 is equal to 79735.46. We have got the value of x0 by x10. But we need to find out the value of x10, they have asked. So therefore x10 is equal to x0 by 79735.46. But what is the value of x0? The value of x0 is given in the problem statement. The amplitude of body after 10 cycles, find out if the initial amplitude is 15 mm. The initial amplitude is nothing but x0. It is given as 15 mm. So 15 divided by 79735.46. So the value of x10 is found out to be 1.8812 into 10 raised to minus 4 mm. So therefore the amplitude after 10 cycles is found out to be 1.8812 into 10 raised to minus 4 mm. So this completes the problem number 3. Let us go for the problem number 4. Let us go for the problem number 4. Let us solve the next problem, that is the fourth problem in the today's class. Take down the problem statement. The measurement on a mechanical vibrating system, the measurement on a mechanical vibrating system, the measurement on a mechanical vibrating system shows that the measurement on a mechanical vibrating system shows that the mass of 10 kg shows that the mass of 10 kg and that can be combined to give an equal spring stiffness, that can be combined to give an equal spring stiffness 5 Newton per mm, equal spring stiffness 5 Newton per mm if the vibrating system have a dashpot attached, which exerts 40 Newton, when the mass have a unit velocity of 1 meter per second, 1 meter per second. Determine the first one, critical damping coefficient. Second one, damping factor. Third one, logarithmic decrement. Fourth one, ratio of any two consecutive amplitudes. ratio of any two consecutive amplitudes. So first write down the given data. Whatever the data they have given, let us understand. The measurement on a mechanical vibrating system shows that the mass of 10 kg, that is mass is given, that is 10 kg, and that can be combined to give an equal spring stiffness. K is given, equal spring stiffness 5 Newton per mm, so which has to be converted. So K is equal to 5000 Newton per meter. If the vibrating system have a dashpot attached which exerts 40 Newton, the force is given. When a mass have a unit velocity is given v, that is x dot is equal to 0.1 meter per second. Determine critical damping coefficient. Determine critical damping coefficient. Second one, damping factor. Third one, logarithmic decrement. And fourth one, ratio of two consecutive amplitudes. So first one is asked is critical damping coefficient. First one, what they have asked? They have asked us to the value of K is given as 5000 divided by M is 10 kg. So the value of omega n is found out to be 22.36 radian per second. So substitute it here. So we get 2 into M is given, that is 10 kg, into omega n we have found out, that is 22.36. The value of critical damping coefficient is found out to be 447.2 and the unit is Newton second per meter. So we have found out what is the critical damping coefficient. Next, let us go for the second one. What is asked in the second question? They have asked us to find out damping factor. They have asked us to find out the damping factor. So damping factor is given by zeta and it is nothing but C by Cc. So the value of C they have not given and Cc we have found out. So how to get the value of C? F is equal to C into x dot. So the value of F is given and the value of x dot is given. You can find out the value of C and the value of zeta is found out to be 40 divided by Cc is 457.2 and it is found out to be 0.0849. So we have done the second one. Third one is asked is logarithmic decrement. So third one asked is logarithmic decrement. That is delta. Logarithmic decrement is given by the equation delta. So delta equation is 2 pi into zeta divided by under root of 1 minus zeta square. So we have calculated the value of zeta. So 2 pi into the value of zeta is 0.0849 divided by under root of 1 minus 0.0849 whole square and the value of delta is found to be 0.564. The value of delta is found out to be 0.564. So let us go for the fourth question, that is ratio of any two consecutive amplitudes. Fourth one. that is the ratio of any two consecutive amplitudes. Ratio of any two consecutive amplitudes, that is nothing but xn divided by xn plus 1 is equal to e raised to delta. The ratio of any two consecutive amplitudes is given by xn plus 1 is equal to e raised to delta. So we know the value of delta. So therefore xn divided by xn plus 1 is equal to e raised to 0.564. So the value of xn divided by xn plus 1 is e raised to 0.564 is going to give us the value of 1.678. So this completes the fourth problem. So now we have completed the 4 problems. Let us go for the